Okay, continuing the notes. 45, these 45 degree, 45 degree, 90 degree, these special right triangles. Right? Why do we work with these? What's so important about these? These 45, 45, 90 triangles are found in squares. Square is a very popular shape for engineering, for construction. If you look at tiles on your floor, windows, okay? This is why this is important, because these are found in squares, right? If I draw a square here, we know a square is a perfect four-sided geometric shape. It's a perfect quadrilateral, right? If all these sides are exactly congruent, if all these sides are congruent, we know that about a square. And we know all the angles are what, 90 degrees? Where's the 45, 45, 90 triangle? Well, when you cut it down the middle, down the diagonal here, right? If I'm getting this 90-degree angle and I'm going right through the middle, and the same thing with this one, dividing these two into, these 90s into halves, that makes this 45, and this makes this another 45. Same thing here, 45, and same thing here, 45, right? Because I went right down the middle. I cut this 90 degree in half. That makes these two 45s. But you're actually left with what? With one 45, 45, 90 here and another one over here, if you see it, right? There's your 45, 45, 90 triangle. Or there's one up here too as well, like I'm saying. So the sides are the same. But now these angles over here, see, there's your 45, 45, 90, and this one's 90. This one's 90. And this is 45, 45. Right, and see these two sides are the same. These legs, see your legs here are the same, they're congruent. Okay, so because of the fact that these legs are congruent, whatever this measure is, I'm going to call this measure x, and this is what you're going to use. You're going to call this measure x. If this one's x, well then this one's also x, right? If this is 8, this one's 8. Right, just like over here on the square, if this side's 10, then all the sides are 10. If this is x and this is x, and from the previous notes, remember I told you that the hypotenuse is the measure of the leg. Remember I told you it's the measure of the leg, the hypotenuse. I put this in the other notes earlier. Is whatever the measure of the leg is times what? Times root 2. Well, in this case, the measure of the leg is what? Well, we don't know it yet. It's x times what? Root 2. Right? If this is 5 and this is 5, okay, only these two are going to be 5, not this one. They're not all three going to be 5. See, that's a mistake. The hypotenuse, which is the longer diagonal side, will not be the exact 2 as the legs. It's going to be whatever the measure of the legs times root 2. So let's go through some quick examples here with some squares, right? So let's say, example, let's say you have a square I know this is a square and it has a side 6. Well, What do I know about a square? Well, if that's 6, then all the sides are congruent. That means they're all 6, right? Question is, how much is this diagonal? Or you can also go this other way, the other diagonal over here. But if I'm trying to find this diagonal here, how would you do that? Well, simple. We know this is going to be a 45, 45, 90. Right, we cut that in half. This one's 90 right here. This is your 45, 45, 90 special right triangle. And I know these sides are 6. Question is, what's this one? Well, we mentioned over here, it's going to be the value of the side, which is 6 times what? Root 2. That's it. That's all you have to know. It's whatever the measure of the leg is. Doesn't matter whether it's this one or it's this one. It's a measure of the leg. They should look the same. Times root 2. That's it. All right, one more simple one. Another square. That has side 13. What if they draw the diagonal this way? It doesn't matter. Let's say you have a square and the side's 13 and they're asking you how much is the diagonal. Well, you already know you're dealing with a square, so all the corners are 90. And if this one's 13, the other leg is also 13, right? Because the sides are all congruent. You have what? Another 45, 45, 90. Right, here's 90. And these are the 45, 45. We know these are what? The legs, 13 will be the same. What's going to be the measure of this diagonal side? Not 13. Not going to be the same as this. It's going to be what? The hypotenuse is whatever the leg is times what? Times root 2. So it's going to be 13 root 2. Okay, so in your assignment, you're going to see problems like this. And again, they'll rotate the triangles, they'll make them look different. They're just going to give you a triangle, right? So let's say it looks like, let's say they put it this way. And they're going to put something like A, B, and then they'll put a number here like 4. You see, they're going to put all these other letters here. That just means that they want you to find this value for this letter A, the length, and then the length for length B. And then something's going to tell you that this is a 45. We're all dealing with 45. Okay, so this is 45. Okay, what I need you to do is forget about these letters here. Don't worry about that. What I need you to do is just look at it with only the information that's important. The only information that I know that is important is that if it's 45, this is 45, that means this is 45, and that means this is 90. It's one of these special triangles, and I got one of the legs. If you have one of the legs, guess what? You also know the other one. If that one's 4, this one's 4. Right? So in that case, what? A will be 4, right? The value of A is going to be 4, but forget about that. And then what's going to be the hypotenuse side? Not 4. It's going to be 4 times root 2. And if you put 4 root 2 in the calculator, you'll see it'll give you like 4 or 5 point something. It's going to be a length greater than these two. The hypotenuse is always greater. But if I know the legs, you pretty much know the hypotenuse. It's the value of the leg times root 2. So here's your answer for A. A would be 4. Here's your answer for B. Okay, number 2. What if they put, again, they're going to kind of like turn these and try to make this look confusing. You just got to know which one's which. Here's the 90 degree. And again, sometimes they won't put that. They'll just put the markings of the angles, right? If these angles are the same and they don't put the angle 45, well, that tells you that these are 45. And again, they'll use like, let's say put this is 3.5. And this will be like X and Y. Again, they're going to use different letters. Forget about those letters. Well, you know that this is what? Those are the same. This is 90. That makes this 45. Well, that's this special right triangle. And if this leg is 3.5, is this one 3.5? No, that's not the other leg. The legs are the ones that include the 90 degree angle, right? The 90 degree angle is right there, including the 2. So this is 3.5. This one's 3.5. And what would your hypotenuse be? It's the measure of the legs. In this case, it's 3.5 times what? Times root 2. So just write it like that, 3.5 root 2. That's it. Okay, here's a tricky one. Number 3. This is the one students get wrong a lot. What if I tell you that this one, I'm going to give you a leg. What if this is 8 root 2? And again, I'll just mark these to be congruent. Well, if these are congruent, you know that you're dealing with what? Oh, and then they'll have some other letters here again, just like, it doesn't matter what letters they'll put there. Just ignore them. They'll just probably put like A and B or something, whatever. Well, I know the legs are congruent. I know this is a 45, 45, 90. Now here's where some students will get this wrong. See, they think this one's 8 root 2, but the one with the root 2 is supposed to be the hypotenuse. But see, that's not the case here. The hypotenuse is not the one that has the 8 root 2. It's the leg. Remember, if this leg is 8 root 2, if this leg is 8 root 2, then this one is also 8 root 2. Yeah? The legs are congruent. This one's 8 root 2, then the other one has to be 8 root 2. The legs are the same. Question is, how do you get this one? How do you get the hypotenuse? Well, what did we say has to be true to get the hypotenuse? It's the measure of the leg, which is 8 root 2 in this case, times what? Times root 2, like we've done over here in the past, times another root 2. The question is, how do you do 8 root 2 times another root 2? Well, we've seen square roots. When you do a square root of 2 times the square root of 2, that's just going to give you 8 times 2. The square root of 2 times the square root of 2 is just 2. So that means that 8 times 2 would mean the length of this would be what? 8 times 2 is going to be what? 16. Now that's a different problem from this last one, number 4. What if I put the 8 root 2 like this? If you see the 8 root 2 over here, see, watch the difference. Here they put 8 root 2 as a leg. If they put 8 root 2 right here, and they give you the hypotenuse to be 8 root 2, then this goes. Then this matches the way this is supposed to be, like 4, 4, 4 root 2. See, this matches the way that the hypotenuse should be the one with the radical. So if this is 8 root 2, well, then you'd know that this is what? 8 and 8. Okay? But when they put the radical over here for the legs, be careful, because that's how they try to trick you. All right, good luck with this assignment.